So now this is a bonus video. I'm going to try to keep this short and sweet. We looked at this diagram and the vast majority of this circuit in the last video. The vast majority of the circuit is right there. Instead of an AND logic gate to control the output with these two inputs there, we have two NAND gates that when you combine them, they become an AND gate, because that comes up from time to time. So an AND gate is the basic properties here of if any of the inputs are low, or zero in this case, then the output is low or zero. You need all of the inputs high in order for the output to be high. So that's the AND gate. This is the NAND gate. It's the opposite. So if any input is low, the output's going to be high for the NAND gate. If all the inputs are high, then the output's going to be low for the NAND gate, the opposite of what you see there. So when you tie together another NAND gate, it becomes a NOT gate. Whatever you input there, because they are both the same voltage right there, there's only two states. Whatever you give to the inputs there, it's going to output the opposite. It's a NAND gate. So we have the opposite of an AND gate, but then we have a NOT gate, which flips it, making it opposite again, so that it becomes an AND gate. Just kind of a quick review. So I just added, because we went into long explanation on that in the last video. Now I just tapped in. We have this circuitry here. I just used a little jumper to build the same circuitry over there. And there you can see we have a high output for that NAND gate right there, whereas a low output for that AND gate. If I move this jumper to the positive supply, then, we still have a high and a low. I can move the other jumper as well. I will do that just for a demonstration. Again, did this a lot in the last video. There we go. So the only way we're going to get a low output here is to get both of these high right now. So right now this is floating. It's bouncing back and forth about 60 times a second. There we go. We got that to the positive. So we got high and high. So now we got a low output. That's the NAND gate. And then we got our inverter. It's taking that low output here and it's inverting it so that we have a high output over there. And again, using 220 ohm resistors to protect the red LEDs right there. I think I may have abused that one a little bit more than the other one. Doesn't look quite as bright. Maybe it is. But in any case, I noticed that if you use an LED a lot, even if you don't think you ever abused it, they kind of fade down in brightness a little bit. So if you grab one that you've used a lot and one that you haven't used a lot, or a brand new one might be quite a bit brighter, even though it has the same amount of current flowing through it. But yeah, in any case, for anybody that was struggling to understand what I was saying by the output of this NAND gate being the opposite as the output of that NAND gate, it's actually inverting it along the way. Here now you can see what I mean. This resistor comes from the positive supply, so we know the output is low. It's connected to ground as good as it can. And this LED, the red one, is lit up. So you can see the resistor comes from the negative supply right there. And so it's got to be positive coming out of that output there for that one to light up. They're separate outputs. The output of that one is wired to the input of that one. And these can provide, these NAND logic gates can provide a significant amount of current. With the two of these, we could go up to a total of 50 milliamps of current. If you're using all four, you still have that 50 milliamp current limit. If you're using one of these 74HC00 right there. So the 74HC integrated circuits tend to have similar output capabilities. So earlier video we were using a 4000 integrated circuit that had a logic gate in it, the 4001, and that one really could not provide hardly any output power. So we actually use that to control transistors. It could easily control MOSFET transistors, but not power LEDs. The MOSFET transistors did the inversion that we have here. But again, the output here can provide the power that we need. So, any case, I kind of assume you've been watching recent videos, but even if you didn't, hopefully I explained stuff enough that you understand it. So, we're going to end it there. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.